Hello, today is an explanation of our day 5 notes from Unit 11, which is based on trig graphing. So up until this point, we've been creating the graphs that we've been given the equations for. Today, we're actually going to go in the opposite direction. I am going to give you a picture of the graph, and then you need to decide how to write it. So first things first here. My idea when I look at a graph is like my first impression. What do you think it is? Is it a sine or a cosine curve? So as we discussed in class, sine kind of looks like an S and cosine looks like a C. You've also heard me say several times that sine starts on the midline. So the midline here would be your x-axis. Cosine usually starts off the midline or typically at a maximum. So right here is off the midline. From there, once you decide whether it's sine or cosine, you figure out the amplitude, which the amplitude is just your distance from midline to max or min point. You also decide if you think the coefficient is positive or negative. So keep in mind the graph that you're seeing on the right here is a positive cosine curve. If it was a negative cosine curve, it would be a reflection in the x-axis. Likewise down here, a negative cosine curve would start below the midline as with the reflection in the x-axis. Once you figure out that, then we move on to frequency. How many full cycles are you seeing over 2 pi units? We then figure out if there's been any vertical shifting. So where's the midline? Is it at the x-axis? Has it been up? Has it been down? And that midline is always halfway between your maximum and minimum, or the average of those. Once you have that, you put it all together and create a graph based on, up until the end of this lesson, A, B, and D. So amplitude, frequency, midline. So starting off with the first graph, I'm thinking, okay, first impressions. I'm noticing it's starting on the midline, so my first thought is then, well, this has got to be a sine graph. From there, I figure out the amplitude, which it looks like we are 2 units from that midline, which is y equals 0. Notice how we're writing y equals 0 because it's an equation. And lastly, frequency. Frequency is how many of those sine curves you are then seeing over the course of 2 pi units, which there's 2 pi. I am seeing 1 full cycle, which is why my frequency is 1. Last little question, has my sine curve been reflected? No, because it's going to a maximum first, so therefore it's got to be positive in front. So my final answer, putting it all together, is y equals 2 sine of 1x plus 0, or just 2 sine of x. Moving on to the next guy. Okay, again, first impressions, I'm noticing it kind of looks like just a hill here. It doesn't quite have like that C shape that cosine has. And it's starting on the midline. So that's what makes me think it's a sine curve. From there, it looks like I have an amplitude of 3. Now, as I just said, it kind of looks like half of the sine curve, because you got to envision this is really what it looks like, where your ending point would be 4 pi. You're only seeing half of this curve, which is why then our frequency is 1/2. Midline would still be y equals 0. So then putting it all together with, again, no reflection because it's going up first, it's y equals 3 sine of 1/2 x. Now, the next guy, we obviously have a vertical shift. So I almost noticed that first, actually. Oops, sorry. I was trying to zoom in and then I got messed up in here. All right, so I almost noticed that first. Everything's been shifted up. Here's a max, there's a min. Halfway in between would be at y equals 2, which is why we have that as the midline. From there, it looks like we have an amplitude of 1 because that's the distance from the midline. Now, since we're starting on the midline but we're going down first, that's why there's been a reflection, which is why now there's a negative in my equation. Now, as far as the frequency goes, here's 0 to 2 pi. I'm seeing 2 full cycles of that sine curve, 2 s's, which is why the frequency is 2, and then I put it all together, and that creates my sine equation. So if you need a moment to fill in all these numbers you haven't been able to keep up, you could take a moment now. or just keep in mind that this answer key is on Google Classroom. So moving on to the next page, keep going with this idea. First impression, sine or cosine. Well, this looks like the max, that's the min, here's the midline. We're starting off of the midline, which is why I would pick cosine here. The amplitude, so the distance from our midline is 2. Over the course of 2 pi units, I'm seeing one c, one cosine curve, which is why the frequency is 1. And since it's starting below the midline, that's why we have a negative in front. First impression, sine or cosine? Well, here's your maximum, here's your minimum, so here's your midline. From there, we're starting on the midline, which is why I would say it's a sine curve. I'm also noticing it's going down first, so that's why there's a reflection, so there's going to be a negative in my answer. Amplitude is 3, that's my distance from my midline of 0. Now frequency, over the course of 2 pi units, I am seeing 1, 2, 3 of those sine curves, which is why my frequency is now 3. Put it all together, your equation is y equals negative 3 sine of 3x. Now lastly here, before we make it a little bit more challenging, I'm looking over the course of 0 to 2 pi again. It looks like everything's been shifted down, so between max and min, I have a midline of negative 2. So that's where this is coming from. My amplitude is 1, and then over the course of 2 pi units, I'm seeing 1 full c. Now, over the course of those 2 pi units, I'm starting above the midline, which is why there has not been a reflection, which is why it's positive in front. So putting it all together, this is just y equals cosine of x minus 2. Now, what if our x-axis isn't labeled from 0 to 2 pi? That only really affects our frequency here. So as far as like sine or cosine, amplitude, like that's all the same. Keep in mind, frequency is always in relation to over 2 pi units. So when I look at this graph, I'm like, okay, first impressions, it's a sine curve. I've got 2 sine curves over the course of pi units. So how many would I have after 2 pi units? So that's where I come up with this little chart to help me think about it. And some of you guys will be able to figure this out in your head, and others of you guys are going to want to do this chart. So I set up my little table here where I think, okay, on the x-axis, I am only seeing pi units worth of content, if you will. And I'm seeing 2 full sine curves over that interval. Now, frequency is always, always, always in terms of 2 pi. So I'm thinking to myself, okay, well, how would you get from pi to 2 pi? Well, you would just multiply by 2. So by that logic, I should be doing the exact same thing over here, which is how I'd end up with 4. Now, like I said, some of you guys are going to be like, well, if you have 2 and 2 pi, you'd have 4 and 4 pi. Or I'm sorry, let me say that one more time. Some of you guys are going to say, well, if I have 2 in pi units, then I would have 4 in 2 pi units. And that's great if you figure that out. But again, some of you might want to draw the table and just remind yourselves, like, it's always in reference to how many you would see over 2 pi units. So with that being said, now that I know my frequency is 4, that's what goes here, and that's where y equals sine of 4x comes from. All right, so moving on to the next page. So it starts off the same way. First impression, sine or cosine. It's starting off of the midline, so I'm thinking cosine. And it's also starting below, which is why there's a negative here. So there has been a reflection. Amplitude looks like it's 3. Now the frequency is where things get a little bit tricky. Frequency is always, again, in reference to 2 pi. Here's what's nice. You can actually pull 2 pi off of the graph. I am only seeing 1/2 of this cosine curve over the course of 2 pi units, which is why my frequency is now 1/2, which is what you're seeing right there. Put it all together, that's your equation. Okay, this looks like a sine curve. My amplitude's 4. It has not been reflected. Midline 0. Great. Now, how do we figure out frequency? So, I'm noticing they're giving me pi units. So if I set up a little chart here, On the x-axis, I'm being given pi units, and I'm seeing 1, 2, 3 of those curves. Now, again, frequencies in terms of 2 pi. This is always 2 pi. So how would you get from pi to 2 pi? Well, you'd multiply by 2. So I would do the exact same thing over here, which is where I'm getting 6 from, and that's our frequency. First impressions looks like a cosine curve. It's starting off of the midline and above it, so that's why it's positive in front. Now notice how with my frequency, it's pi, I have to figure out in terms of pi over 2, or if you want, think about it in terms of degrees, 90 degrees. So on the x-axis, I'm seeing pi over 2 units, and I'm only seeing one full cycle of cosine. How much would it take to get to 2 pi units? So again, if you want to think about this in terms of 90 and then 360, it would be pretty obvious, I think, that you're multiplying by 4. So if I do the exact same thing over here times 4, that's where my frequency is coming from. So if I look over the course of 2 pi units, I would see 4 of these cosine curves. And that's where y equals cos of 4x comes from. Okay, first impressions, looks like a sine curve. There's one cycle of sine starting on the midline, amplitude 4, great. Now again, it's pi over 2 there. So if I come up with my little chart, on the x-axis I'm seeing pi over 2, and if you look, I'm only seeing 1.5 of those cycles. So I'm going to put 1.5 here. Now again, you want 2 pi for your frequency, which as we just learned up above, that's multiplying by 4. So if I take 1.5 and multiply by 4, that would be 6. That's where my frequency is coming from, which is why you're seeing it there in my equation. Has not been reflected because it's going up first. All right, now question 12, I just moved the y-axis on you, so that's why it's highlighted here. Whenever I'm determining whether I'm going to write this as a sine or a cosine curve, I just look at the y-axis. First impressions, what do you think? Here's your minimum, there's your maximum. This would be your midline. You're starting below the midline on the y-axis, so therefore that's why I picked cosine. Since it's below the midline, that's why you're seeing a negative in my answer. Now here's where it gets a little bit tricky. Because I put the y-axis in the middle, when you set up your table, you could think about it a couple of different ways. You could think of it as you're seeing half of the curve in pi over 2 units, or realize that pi over 2 and pi over 2 is pi units, and if you look from left to right here, this is one full cosine curve. So I'm going to do it that way. In the x-axis, I'm seeing pi units like in my window, and I'm seeing one full cycle, which means over the course of 2 pi units, I would see 2 full cycles. And that's where my frequency is coming from. So then lastly on this page, same idea here. There's my midline. With reference to the y-axis, I'm starting on the midline, which is, oh, whoops, there's a mistake here, which is why we're picking sine. So sine should be circled there. We have it here, and then we accidentally circled cosine. So this is a sine curve. We're starting on the midline. Now, amplitude's 3, great. Okay, now again, I'm giving you pi units that you're looking at because it's going from negative pi over 2 to pi over 2. So, x-axis curves. So I'm seeing pi units worth of content, if you will. If I count this as cosine curves, which I can from left to right, because sine and cosine are really the same graph, they just have a phase shift. It's just a matter of how you want to write your equation. I'm seeing one cosine curve, and then a half of another one. So that's why I'm going to put 1.5 here. Now just like up above, if I then need 2 pi units to figure out frequency, then that means times 2, this must be 3. and that's where that's coming from. So like I said, I thought about this in terms of cosine curves. It's a little bit more awkward to do it in terms of sine curves because it's like you have half plus another quarter, so 3/4 of it, and then you have another like over here. Like it's just weird. So, I mean, you could do it. That's actually what this math is doing here. You have 3/4 of the graph in pi over 2 units. So if you multiply that by 4, I don't know. It works. It's the same thing, but I personally think about it in terms of cosine here. All right. So let's try writing some graphs in terms of both sine and cosine. So this is where there's technically infinitely many ways you can do this. If I look at this first graph, the easiest thing to do is say, okay, first impressions, here's my midline. We're starting on the midline. I would say that looks like a sine curve. So, with that being said, when I look at this, I have an amplitude of -2. And it's going down first, which is why you're seeing a negative in front. Okay, now how many cycles are we seeing in 2 pi units? Well, I see 1 and a half, which is why you're seeing 3/2 or 1.5 there for our frequency. Now, what if I wanted to write this as a cosine curve? So it technically depends on really what you want to do. So whenever you pick a cosine curve, then you got to pick a maximum or a minimum. So in this case, here I'm going to erase some of my highlighting here. In this case, let's pick a minimum. So let's say this right there. So think to yourself, you're going this way then, okay? So your negative cosine curve would look like this, but then it's been shifted to the right pi over 3 units, okay? So if you take this negative cosine curve, which again kind of looks like that, and then we shift it to the right, it's going to have the same amplitude, it's going to have the same frequency as the sine curve. It's just now I'll write it in terms of cosine, throw a negative in front as well, and then put minus pi over 3 to account for the right shift. Okay, now technically I could have also picked this point right here, but then it would be a positive cosine curve that's been shifted left pi over 3 units. So just for fun, I'll throw that on here too. So that would be a positive 2, excuse me, for the amplitude. Cosine, 3/2, that's all the same. But then since we're going to the right, it would be x plus pi over 3. So pretty much I just pick the y-axis and show how I would be shifting it. This was to the right, this was to the left. Okay, next guy, again, first impression, sine or cosine when I look at the y-axis. So there's also a max of 4 and a min of -2. So since those are different, that tells me my midline I have to recompute. So 1 would be in the middle of that. Now, with respect to the midline on the y-axis, it's starting off the midline, which is why the easiest thing to do is write this in terms of cosine. Over the course of pi units, I'm seeing 1 cycle. Over the course of 2 pi units, I'm seeing 2, which is why the frequency is 2. Now, if I want to write this as a sine curve, I can pick a point on the midline because sine starts on the midline. So let's say this guy. So if I pick that point and notice how it goes down, that means it's got to have a negative in front, which is why you're seeing a negative in front of my equation here. Still would be amplitude of 3, but since I'm technically shifting to the right in the middle of these boxes, which would be pi over 4, that's where that's coming from. Now again, technically I could pick any point on the midline. I could have also picked this point. Now the difference is if you pick this point, that's a shift to the left. So you got to envision it. Your sine curve would look like this, but then it's shifted to the left. So now it's a positive sine curve. So this would be positive 3 sine of 2, but then this would be x plus pi over 4 plus 1. Okay, so it really just depends on what you want to do. So to recap, if you want to write it as a sine curve, pick a point on a midline. If you want to write it as a cosine curve, you pick a maximum or a minimum. And this is one of the trickier things to do. Now the last thing we got to talk about is what to do when you cannot easily identify the period and frequency. So in order to find the period, what you can do is locate the endpoints of one cycle. So max and min points or x-intercepts are good places to look. Find the difference in those x values and then determine the period. From there, we find the frequency by setting our period equal to 2 pi over b and then solving for b. So if I want to write an equation for this guy and I look at the y-axis, it's not very easily starting at either the midline or a max or min. So I really just got to pick one. Okay. So first thing I would probably do is maybe do a sine curve. So if I pick this point right here, that would be a positive sine curve that's been shifted to the right pi over 3 units, which is actually where this is coming from in this equation that I'm about to write. Since it's going up to 2, that's why you're seeing a positive 2 in front. Now, as far as the period goes, look at the difference between these values. If I actually, get rid of that thing. If I actually subtract pi over 3 from the negative pi over 3 and look at the difference between those are 2 pi units. Now, really, you could just kind of look at this and just be like, well, and count your tick marks and be like, oh, wait a minute, but that's the same as it is from here to here, and that would be 2 pi. Well, that works as well. So ultimately, I'm seeing that it's taking me 2 pi units to see one full cycle, which is why then if I do, okay, period would be 2 pi, frequency is 2 pi over b, and solve for that, I would find that the frequency is 1. So at the end of the day, you're seeing one full cycle over the course of 2 pi units, which is why there's a 1 in front of this. Now, technically, I could write this as a cosine curve as well by picking, let's say, like a maximum. So I could pick like this guy right here, which looks like he's being shifted to the right pi over 6 units. So with that being said, that would be starting above the midline, going down like that. And that's why it's positive in front, and that's why there's a shift to the right of pi over 6 units. So again, you got to envision it's like your positive cosine curve would look like that, but then it's shifted to the right pi over 6 units to map onto this curve that I have now highlighted in purple. All right, so next and I believe last, last question of this. I've got my graph here, first impression, sine or cosine. Well, it's not really obvious. If I look at my y-axis here, it's just not easy to tell because it's not starting at nicely at a maximum. It's not starting nicely on your midline. So that's where you just got to pick how you want to do this. And technically, you could pick any max or min or any point on the midline. So let's say I want to write this as a positive cosine curve. Well, then I can pick a maximum like this guy right here. That's a shift to the left of one of these tick marks would be pi over 6. And that's why you're seeing a plus pi over 6 here. Amplitude is 1 unit, positive cosine curve, midline 0. Now, as far as the frequency goes, you're seeing 1 cosine curve over the course of 2 pi units, which is why the frequency is 1 in front of this. Okay, so again, like you could literally take the difference from these, or I would probably just count the tick marks and be like, well, that makes sense. If I'm going from here to here, just shift that over a little bit and then it would go from 0 to 2 pi. Now, what if I wanted to write this as a sine curve? You could pick a point on the midline. So you could pick this guy right here, which looks like it's to the right pi over 3 boxes, which pi over 3 is 60 degrees. That's why I know that's 2 boxes. Okay, because again, we know every 3 boxes is technically 90 degrees or pi over 2. So with that being said, that's where this minus pi over 3 is coming from. Since this is then going down first, that's where the negative is coming from. Now, if I wanted to, for fun, to do this as a sine curve, I technically, like a positive sine curve, I technically could pick like this point and say shift to the left, but it's a little bit trickier to figure out like what that tick mark is. So frankly, I usually don't pick the tick marks unless I know exactly what they are. So I encourage like the smallest ones. So like I said, your two options here that I think are the easiest are this positive cosine curve or this negative sine curve. Either one works. But technically, there's infinitely many depending on how you want to start it and then shift it. Now, with that being said, these kinds of problems will not be on your quiz tomorrow, but they will be on your test. Now, problems like these that I'm showing right here, these could be on your quiz tomorrow, which we will review before your quiz as well. So with that being said, your homework is then 10-5. I think that's the number we're on here. Yep, 10-5 or 11-5 because we're in Unit 11. And I'm going to encourage you to even look ahead in your homework packet because there is a mid-unit review. So then that way we already know what kind of questions we want to ask tomorrow before we then do the quiz for the second half of the period. So expect a quiz that is 1 page front and back. I got a couple graphs on the back, and I will give you a couple of these problems of this caliber where you have to determine how to come up with the sine or cosine curve, but I will not have any phase shifts in it. So don't worry about the side to side. So if you can do amplitude, frequency, midline, and reflection, you should be in good shape. I will likely post some things on Google Classroom for you guys as well, so stay tuned to help you prepare. Other than that, I am going to conclude my video. Good luck.